Okay, so today we're talking about representing linear functions. Basically, we're going to solve linear equations with two variables and graph linear equations using ordered pairs. So a tennis match with Venus Williams served a tennis ball at a speed of nearly 60 meters per second. So we are to complete this table. So this is my x values, this is my y values. So in 1 second, and she did 60 meters per second, so 60 times 1 second would be 60 meters. In 2 seconds, it would be 60 meters times 2 seconds would be 120 meters. In 3 seconds, it would be 60 meters per 3 seconds, or 180 meters. Okay? Now we could graph that. So when you have grid paper, this is going to be your origin, or 0, 0. And since I'm going from 60 to 180, I would number these by 50s. Okay? And then number these by 1. And now 1 and 60 would be about right here. 2 and 120 would be about here. And 3 and 180 would be about here. So there. That is the graph. Now they want to know, is the graph a function? Yes, it is a function. 1x goes to each domain, or one range to domain. It also would pass the vertical line test. And then what would the equation be? Well, we could be y equals 60x. Okay? And that's what we're going to be talking about today. So, an equation such as y equals 60x is called a linear equation. A linear equation is an equation whose graph is a line. A linear equation is also a function because each member of the domain, the x value, is paired with exactly one member of the range, the y value. The solution of the equation with two variables consists of two numbers for each variable. That makes the equation true. One way to solve it is to make a table. Okay? Remember that coordinate pairs would be x, y with parentheses around them. Okay? So we are to find four solutions of y equals x, or y equals 7x. And we are to write solution as ordered pairs. So they give us our x's. We put another table with an actual equation, and then we plug our x's in for x, and then we solve for y. So y equals 7 times negative 1 is negative 7. Y equals 7 times 0 is 0, and so forth. Then we rewrite those x's and y's, and we bring them over and we write them into coordinate pairs. And so the four solutions would be negative 1, negative 7, 0, 0, 1, 7, and 2, 14. Okay? All right. So let's do this one. So we have to find four solutions for y equals 4x minus 10. They give us the x's, so we would have just plug in what we know for x into x. So y equals 4 times negative 1 minus 10. That would be negative 4 minus 10 would be negative 14. So my ordered pair would be negative 1, negative 14. Then we have y equals, so the equation does not change. 4 times 0 minus 10 would give me negative 10. So 0, negative 10. Then I have y equals 4 times 1 minus 10. That would give me negative 6. So 1, negative 6. And then y equals 4 times 2 minus 10, which would give me negative 2. So 2, negative 2. And that is my four ordered pairs. Okay? All right, you try this one, then come back and see how you did. Okay, so you should have put your equation in the middle, plugged in negative 1 for x, then 0 for x, then 1 for x, then 2 for x, and solved them, and got negative 11, negative 6, negative 1, and 4, and these would be your ordered pairs. Negative 1, 11, 0, negative 6, 1, negative 1, and 2, 4. Okay? All right, I'm sure you did well. When solving real-world problems, check that the solution makes sense in the context of the original problem. So, for example, games cost $8 to download onto a cell phone. Ringtones cost $1. Find four solutions of 8x plus y equals 20 in terms of the numbers of games x and ringtones y. Darcy can buy with $20, and then explain each solution. So we have the equation. We really want to get it to where it's y equals. So we could subtract 8x from both sides. And we end up with y equals 20 minus 8x. Then we can make ourselves a table. We can pick 4 different x values, plug it into the equation we just did, y equals 20 minus 8x. So everywhere there's an x, we plug it in. We solve for y, and then we get our 4 ordered pairs. Now we have to explain what they mean. So we got 112. That means she can buy 1 game and 12 ringtones. We got 2-4. So that means she can buy 2 games and 4 ringtones. And then 1/4 and 18. Well, you're not going to buy 1/4 of a game, so that does not make sense. So that would not actually work, okay? So it doesn't make sense. And then 5, -20. Again, you're not going to buy a negative amount of ringtones, so that's not going to work. So if we had to pick pick correct solutions, the first 2 would actually work. They would be correct solutions. The other ones don't make sense for this problem, okay? So that brings me to discrete data. The solution in the one we just did represents discrete data because only whole number values are appropriate. Discrete data have space between the possible data values. Continuous data can take on any value, so there is no space between data values for a given domain. You can determine if data that model real-world situations are discrete or continuous by considering whether all numbers are reasonable as part of the domain. So for example, the number of fish a tank can hold. That would be discrete data because you'd only be looking for whole numbers. You wouldn't do 2.5 fish, okay? On the other hand, if you were looking for the size of the fish in the tank, you might have a 2.5-inch fish. So that would be continuous data because it's not just whole numbers. It would be all the numbers. And then the number of shirts you can buy. Again, you're not buying 1/4 of a shirt, but the amount of money a shirt cost would entail those numbers in between the whole numbers. So that's the difference between discrete data and continuous data. So now we're going to talk about graphing these linear equations. So the x-coordinate is the coordinate where it crosses the x-axis. So this is the x-axis, this line right here. And the point where it crosses, that's your x-intercept, okay? And then this is your y-axis, and the point it crosses the y-axis is called your y-intercept. And since 2 points determine a straight line, a simple method of graphing a linear equation is to find the points where the graph crosses the x-axis and the y-axis and connects them. So if we can find those 2 points easily, those are 2 easy points to get. For example, we have to graph -2x plus y equals 4. Well, again, we could find the x-intercept. All we have to do is plug in 0 for y and solve for x. That would give me -2x equals 4. Excuse me. Divide each side by -2, and x equals -2. So we would have -2, 0 as our x-intercept. That's where it's going to cross the x-axis. Then we can look and put 0 in for x. And when we put 0 in for x, that's -2 times 0 is 0. So that leaves us with y equals 4. So the y-intercept, or where it's going to cross the y-axis, would be 0, 4. So -2, 0 is here. 4, 0 is here. And once you get 2 points, I can draw a line through the points and make my graph. Okay? That's how you can graph using the x-intercept and the y-intercept. All right, so this says graph 2x plus y equals 6. Well, I can subtract 2x from both sides, and I end up with y equals 6 minus 2x. Excuse me. Then I can pick some x's and solve and graph. So I could pick, like, let's say, let's start with 0. So y equals 6 minus 2 times 0, which would be 6. So I have 0, 6. So 0, 6 would be right here. Then let's say I do 2. That would be y equals 6 minus 2 times 2, which would give me 6 minus 4, or 2. So I have 2, 2, which would be here. Now at this point, if it's not asking for a certain number, I can graph the line. I know where the line is. I have 2 points. But I could keep going. I could say 4, y equals 6 minus 2 times 4, which would give me negative 2. So 4, negative 2, which would be here. And then I could go 6. Y equals 6 minus 2 times 6 would be negative 6. So 6, negative 6. That would go right here. And then I just draw a line through the points. And now it's graphed. Okay? All right. You try this one. Come back and see how you did. All right. Let's see how you did. So I would change that negative 4x plus y equals negative 3. I could add 4x to both sides and add y equals negative 3 plus 4x. Pick 4. I could pick 2. I chose to pick 4 random x numbers. Plug those into x and solve for my y values. And then I got my coordinate pairs, 0, negative 3, 1, 1, 2, 5, and 3, 9. Plug those points in, connect the dots, and my graph is done. If you got any questions, let me know. One quick thing. If you happen to see, for example, y equals 2, let's say, okay? Well, that is a horizontal line. That means everywhere that y equals 2, there's a line. So it doesn't matter what the x's are. X could be 2, y is still 2. X could be 6, y is still 2. So wherever. So if you have something like that and they ask you for ordered pairs, you can pick any number you want to for x as long as the y is 2. Okay? It's a horizontal line. All right. Now, have a great day.